Okay, welcome to another video lecture. In this lecture we're going to focus a little more on C++, both the object-oriented and the non-object-oriented concepts involved in programming in C++. So we've already gone through this sort of evolution, if you will. We talked about structs in C and how those can also be used in C++ and basically get turned into a class. And the primary differences have to do with the ability to do inheritance and also the default of the protection mechanisms like public, private. Both structures and classes let us do data encapsulation, and they also let us do, to some extent, operational or behavioral encapsulation as well with the functions. So we're going to go through a quick example using a struct and then sort of morph that into a class. So here's a struct that would implement a stack. We've talked about stacks before, stacks with the last in, first out type thing. So this one uses an array, and it's got a basic structure defined that, of course, only has data in it. And then we create external functions that we have to pass the stack to. In this case, s is our stack variable. And then we can do things like push and pop and check to see if the stack is empty, etc. So this is good old C code. We can't incorporate these things like push and pop. Well, we can, but we didn't in this case, into the structure. So they're external to the structure, so that's why we have to keep passing the structure in. So the problem, of course, with structures, though, is that we need a different structure for each kind of data that we're going to put on the stack, use the stack for. We have to deal with the overflow issues, etc., etc. So what we would like to do is put the data inside there, and we can do that in C using the stack structure. We can put the data in there, the push, the pop, and the is empty. So now they're defined as part of the stack, even though here we're just showing their prototypes. We've done the implementation outside, although we could do the implementation in here as well. It would just make this structure definition much longer. And so now we have this stack : notation, which indicates that this push function is part of the, in this case, structure stack. Later on that'll be a class. So this is kind of like a first name, last name kind of thing. We're saying all of these are part of the family name stack, and the particular first name, if you will, is push or pop or is empty. Because I could have push, pop, and is empty for some other family, if you will. Maybe it was Q, for example. And the code is basically the same as it was before. And then I could use it in a main like this. I could create an instance of the stack. I could do a push, a pop, etc., etc. I can print out information. Again, using the member operator, but we're still dealing with it as a structure. So everything defaults to public in the structure. In C++, we're going to morph that into a class, and that gives us some better protection, plus some other things that we can do later that we can't do with a structure. So the members and everything are still defined the same way. We have member variables and member functions. The nice thing is we can hide the data, so we can put the data into a private area. Although we can do that in a stack too, but everything defaults to public. In a structure, everything defaults to public. Here everything defaults to private, so we have to make very clear what the public parts are. So we have this data hiding capability, if you will. Private data and even private members are hidden unless you're a member of the class. So we take this struct that's defined like this, and there's certain things we can do. Here we've added the private keyword in here and the public keyword, so now the functions are public and the data is private, so I can't access the data directly from like main, for example. So s.top would be an illegal operation. S.data bracket 17, accessing the array directly would be illegal. But push and pop and is empty are legal. I can do those publicly, so from like main. And once we've done this, we basically have done everything to make it a class. We could simply replace the word struct with class, and this would now be a C++ class, declared in the appropriate way, with private things being private and public things being public. And just remember, though, that in a structure, if you don't put these private and public keywords, everything's public. Whereas in a class, if you don't put the private and public keywords, everything's private. So classes err on the side of caution, if you will, in terms of access permission. In C, initialization of variables left to the users. In C++, that's not the case. So if we declare a variable, for example, um, we don't necessarily have to initialize it, but we can't use it until that happens. In C++, we have a special sort of initializer member of each class by default called the constructor. So it's responsible for initializing objects when they're created. You can create your own, or the compiler will create one for you. If you create your own, then you have choices about what you can do. So the constructor is a special function. It always has the same name as the class. We don't directly call it, we cause it to be called when we create an instance of that class. It can take arguments, it can be overloaded, it can have default arguments. The one big difference, it has no return value, not even void, because it's not directly called by you, if you will. And also the name is the same as the class name. So in this case, for example, I could create a stack constructor, and inside that constructor I could do things like initialize top to 0. If I want to initialize the data elements in this array, I can use memset or something to initialize all those variables, etc. So notice stack is the name of the function. It's a member of the stack class, so it has the same name. It doesn't have a return value declared at all, not even void. And we can use it to do initialization. We can do other things in there too, like we can open files and things like that. And since there's a constructor, you can probably guess that eventually we'll be talking about some sort of the opposite entity, which is a destructor, which is something that gets called when a particular object of a class type gets destroyed or goes away, goes out of scope, and we can do cleanup stuff in there, like close files or whatever we might want to do. Okay, so we can do things like stack S. That would create one, and with the empty parentheses, it means I'm not passing any parameters. And that's how we would call this one we just created. It would initialize top to 0. And once we do that, then we can call all the other methods, etc. We can also create constructors that take arguments, like if we want a top to start at something other than 0 or whatever. And we can also overload the constructor and have some that don't take arguments, some that do take arguments, some that take different numbers of arguments and different types of arguments, etc. And we'll see an example of that. So here we have two versions of the stack constructor. One that's empty, in other words, doesn't have any arguments, so it's going to just set top to 0. The second one lets me initialize the stack with some data, as well as then the number of elements that are currently in the stack, if you will. So this constructor, I'm passing an array, so I'm going to go through the array, and I'm going to put all the data into the array, and then n is the number of things that I'm passing in. That was the size of the array. So I can sort of preload the stack if I wanted to before I start using it. So that's the second version of the constructor lets me do that. And I can use either one when I create a new stack entity or stack object in main, for example. Depends on whether I want an empty one or I want one that's already preloaded with some stuff that I could then add to, remove from, etc. So in this example, of course, we haven't taken care of things like Stack Overflow. What if we try to push more than 100 things on the stack, because that's the limit on the array size that we set in this case. So we can use dynamic arrays. Is one of the ways we could do that. So we can, instead of having an array limited to 100, this is kind of like transitioning from homework 1 to homework 2 with the gradebook, where everything was fixed size, and now we're going to go with a dynamic size. So we could do that, and that's what this particular example does. So now here our class stack is declared, and the data is a pointer, much like what we did in your second homework assignment. And now we have a capacity, so we know how big it is and whether we know whether we need to add more data to it. And then we initially, in this case, here's one of the constructors, and this one defaults the cap to 100. I can specify a capacity. If I don't specify, this is called a default argument. This is basically implements two versions of the stack constructor. One where you don't pass it any arguments, in which case it'll set cap to 100. Or if you pass an argument like 110, then it would use that value instead of this default value. So this really implements two constructor calls. Then here's the one where I can preload it with a particular array of stuff. Now I've created some other methods where I can find out what the current capacity is. And then of course I got my push and my pop and my isEmpty. These were the three original functions. Now what happens is in this, for example, the stack constructor where I can preload, I have to set the capacity to something. I'm either going to set it to 2 times n or 100, whichever is larger. And then I'm going to dynamically allocate space based on the capacity. And then I'm going to load up the initial data. In the case of one that all I pass is a capacity, or I don't pass a capacity, it uses this default value, then I'm going to set top equal to 0. I'm going to set the capacity to 100 or cap, as long as cap's greater than 0. And I'm going to allocate space, but I haven't put anything in that space yet, and then I'll use my pushes and pops to do that. Now, push changes a little bit because now I've got to check when I'm adding something, I need to check to see if I'm still less than the capacity. So if top is less than the capacity, then I'll just go ahead and push it on there. Otherwise, I need to double the capacity in this case. So I'm going to take capacity star equal to, allocate new space, copy everything over, delete the old space, and then assign the new pointer to my permanent pointer that I've been using. And then I can add the value to it. This is the same algorithm, the same set of steps that we talked about doing in the homework 2. However, this one with new, there's not like a realloc, so you have to do the work yourself. New is smarter, but you have to do the work that realloc would do in terms of creating the space, copying, and then updating the pointer. Okay? So this should give you a little bit of an idea of some of the things that we can do in C++. So we introduced several new concepts here, which we'll go over again in a future lecture in more detail. We introduced the concept of constructors. We introduced the concept of course, the class and migrating from the structure to the class. We also saw examples of function overloading with the constructor. We can do that with other functions as well. And we also introduced the concept of default function arguments, where I can have a function argument that if I don't specify it, it will make an assumption for me and use a particular value. So that's a powerful capability as well. Gives the user the ability to say, you know, I'll just use whatever the standard value is, for example. Okay? So again, we'll go over all these concepts in a little more detail in future lectures, as well as cover them in examples and things that we're going to do during the class time. So be sure you come to class time with questions about these lecture notes, as well as questions about your upcoming homework assignments.